All right, take two of Cloud Posse DevOps office hours for August 24th, 2024. No, so I'm going to start this over again. Thanks everyone for joining our office hours today. It's August 24th, 2022. My name's Eric Osterman, and I'll be leading the conversation. I'm the founder and CEO of Cloud Posse. We're a DevOps accelerator, and that means that we help companies own their infrastructure in record time by building it together with you and showing you the ropes. So if that sounds interesting, head over to cloudposse.com/quiz to get started. You'll be prompted with a quick little form and have a chance to book time with me directly. So for those of you new to the call, the format for today is very informal. My goal is to get your questions answered. Feel free to unmute yourself at any time if you want to jump in and participate. If you're tuning in from our podcast or YouTube channel, you can register for these live and interactive sessions by going to cloudposse.com/office-hours. We host these calls every week. Our call today is recorded. We'll automatically post a recording of this session to our YouTube channel. So if you enjoy the content and want to support what we do over here, please hit those like and subscribe buttons. Just go over to youtube.com/cloudposse. So with that said, let's get into it for real this time. So thanks, Linda, for catching that. The first announcement is that we have our new DMS module. We've been working with DMS now for the better part of a year and a half. And there's been a lot of problems with the Terraform provider around DMS that made Terraform almost wholly unsuitable for managing DMS. We had to use lots of local exec and other things. We were contemplating adding some things to our AWS Utils provider, but it turns out that all those things that we had to do the first go around with DMS have since been resolved. So now there's a DMS implementation here. If you go to examples complete, it's a fully functioning implementation of DMS that resembles something that we've done for one of our customers. And that is tested with automation using TerraTest, just like all of our other modules. Basic smoke test to ensure that it comes up and is functioning. So check that out. Next announcement. Any questions on that before I move on? And
a question on the DMS. So what databases you support for the DMS?
I believe we support whatever is handled natively by the Terraform provider. I don't know what that is off the top of my head, but every feature of the Terraform, of the AWS provider and the resources for DMS is handled by the module. And we implement that as multiple pieces here and submodules. So I'm not sure off the top of my head what it supports. But if you post it if you ask the question in our office hours Slack channel, I'll tag Andre, who wrote the module, and he'll answer it.
Thank you.
Good question. Thanks. We should add that to the README. Next one is announcement from GitHub Actions. GitHub Actions has been releasing nice new features every week for the past month here, and that's cool. So if you aren't already using GitHub OIDC Connect with your GitHub Actions, well, you should be. Basically, this is how you use GitHub Actions without having to hard code any AWS credentials in your environmental secrets within GitHub. So GitHub OIDC has been around for a while, and basically you trust GitHub as a provider, as an OIDC provider, and then set up your IAM roles and policies to trust it. So this adds additional support, including enterprise capabilities, so you can track the issuer. But more specifically, you can now tie IAM roles and policies to specific repositories, and that makes it even more fine-grained. So I think this is much needed to reduce the attack surface using GitHub Actions with AWS and deployments and Terraform more specifically. So with this, you'd be able to give a team their own Terraform repository, for example, and then set up some fine-grained IAM roles that describe what that Terraform in that repository could do, and then use GitHub Actions to automate that. Matt Calhoun, anything else you'd like to add to that? Not sure if he, doesn't look like Matt made the call today. No worries there. Then any questions on that before I move on?
Eric, just quickly back to the DMS. The targets that I'm aware of are RDS for Oracle as well as RDS Aurora.
Okay.
I'm not sure of any other targets that are currently supported.
Okay, thanks for looking that up. Appreciate that. And then going back, next announcement I would have is, or I have is something that just came across my radar this morning. I don't, to be honest. Well, okay, I'll add my 2 cents afterwards. But so anybody who's been working with Terraform for some time now understands how multi-cloud is achieved with Terraform. It's not that you write your Terraform code once and it miraculously works on Google Cloud and Amazon and Azure. Instead, you got to write the Terraform code, write the modules for each one of those providers. Now, if you wanted to, you could then abstract that away in a module, but then that module would still need to have one provider block for each cloud. So not ideal. The other, there's been kind of this movement, I don't want to call it a movement towards multi-cloud, but there's been this myth, I think, in infrastructure as code that you can write your infrastructure as code one time and then just miraculously it's going to work wherever you want to do it on any cloud. That hasn't been the story for Terraform, but it's really a consequence of the convention of Terraform. And the convention of Terraform is to write one provider per cloud API, like per platform. So in this case, you would have a provider for AWS's APIs, one for GCP and one for Azure, etc. Well, what if somebody wrote a Terraform provider that abstracted that all away? So when you wanted a VPC, you just requested a VPC, and that the job of the provider was to do all that dirty, all the dirty job and heavy lifting. So this is in the Terraform registry, and they support a number of primitives as it is right now. They show an example, I guess, in their docs here. I forget where I saw it earlier here, of defining, like, or was it defining? I saw an example for defining a VPC in a cloud agnostic way. So it's interesting. I think just using a logical argument of how hard it is for Terraform to manage their ecosystem of providers, more or less somebody trying to create the provider to end all other providers, like the provider that's going to encapsulate all other providers and normalize this, is that's a grand and lofty ambition, but I just don't see it as succeeding in the long run. Anyways, I don't know how they're going about it, technically speaking. Maybe they have some magic behind the scenes and some APIs that this works with. It is it looks like it's a venture-backed startup in the early stages, backed by Techstars here. And they're currently supporting Amazon, Google, and Azure. Anyone else take a look closer at multi?
I haven't looked at multi personally, but I've looked at Pulumi, which tries to do something similar. I guess the challenge becomes the language that you're using, because if you're not familiar with the AWS background, you might not be calling a VPC. You might be calling it something different.
Right. And how do you normalize that nomenclature?
Yeah.
And is that abstraction necessary? Like, are you going to be fighting the abstraction more than just writing it?
So the other observation that I would offer is a tool like this, it seems, would be very opinionated in the decisions that it makes for any particular provider. And so if it is opinionated, how do you override those things? Like the concept of a server size, like a T2 micro versus whatever that same thing is in GCP or Azure. How do you tell this tool, I need a server of this size? And maybe they don't, it looked like when you did a view of what they provided, they didn't have servers. It looks like it was more network type stuff.
Just a few basic objects to start with. Yeah, well, they have tried to normalize it like a network interface, a virtual network, which is the same. Well, okay, I'm going to go out on a limb here. I'm thinking that's the VPC, but maybe there's another object for a VPC.
But I see virtual machine down there now. I didn't see that before. So this is like,
Yeah, so
how do
that's
you
it,
say,
yeah.
give me this size server on this particular cloud versus some other cloud?
Yeah. Yeah, so this must be the VPC resource, the subnets in the VPC, and then provisioning the VM on that. And then you could do that on.
Looking at that size, if you go to the AWS console, what's a general micro? I mean, you don't see that size. Line 16.
I believe on
Yeah.
some documentation, they've actually got it mapped to like general micros this between the clouds.
Interesting.
Yeah, that's what I'm saying. So there'll be some sort of opinionated determination that says a general micro is this on AWS and is this on Azure versus, whatever you think a general micro might be for your needs on any particular given cloud. Probably the same thing for databases and so on. So you'll just have to assume these opinions for your use of this particular provider.
That's interesting because I feel like the whole approach of labeled sizes of instances was always wrong from the get-go, and that you should just state what you want and then it picks something that fits those requirements. And that seems like that would be a universal across platforms more so. AMD, Intel chip, you need 4 cores, you need 64 gigs of RAM, and then it fits that based on some constraints or price, for example. That could be a fifth argument. But those seem like everything costs money on every cloud for the most part. If not, please let me know. And then everything uses some amount of resources in the shape of the CPU and memory. So
I was with you on when you were saying that, but I was going to say until you said price as its fifth argument, because I was going to say if you were going to pick it for you, of course they're going to pick the most expensive one. But if you did add price as the fifth argument, that would be nice.
Yeah. Well, I think everyone would be optional to some degree, and then you could say it always picks the cheapest one or some selection algorithm.
And how do you quantify then for spot pricing or spot instances?
So there'd be a range of price that you're tolerant. Yeah. And spot is a concept that exists in a lot of places, ephemeral instances. Matt, Calhoun?
Yeah, I was just gonna say I linked the doc that's actually like how they do VM sizing, and it's actually in the chat. If you click on that, it's actually pretty. It's pretty well thought out. And it seems to align pretty well. I don't think you're sharing that screen if you.
Yeah, I'm trying to see where you was posted. No, I didn't open it yet.
Oh, sorry,
where it was.
Yeah, that one. That one.
What I hate is being a Zoom organizer, suddenly it decides you need to have 15 different Zoom windows that you have to trace down to find what you're looking for.
Yeah, so I was just going to say they took the general categories that all of the clouds seem to have is like, general instances, compute optimized instances, and memory optimized instances. So it's interesting they don't use like, they don't use like some other instances like the storage optimized or whatever thing, and it does. I think Jim just wrote the same thing that I noticed is that they're using on AWS they're using T's instead of M's for general. It doesn't look like you really have like a. Doesn't look like you really have. It just doesn't feel
scalable when there's probably these days there's probably 1,000 instance types on AWS and all the permutations. It just doesn't feel scalable to take this labeling approach.
Although it does, but there is a thing in there that you can in the actual block itself. You can do AWS _ overrides, and then you can say instance type and actually specify the instance type. Yeah.
And then undo the whole thing that we were trying to do.
Well, I mean, sort of. I mean, it's like saying you want a you know, a general purpose. I mean, it's pretty good. It gives you like the ability to deploy common scenarios with you know, escape hatches when you need them, right? So it's basically saying for any of the clouds, you can override certain parameters as necessary. And you could put those in for all 3 clouds if you're deploying to all of them.
So it's interesting. Do you know if this requires using some SaaS component that they offer as an interface or an API, or is it all 100% handled by the provider?
That I didn't look into. I didn't actually look into how it all works.
You can, so I've played with it a little, and I believe you could run it locally, but there is a API key that they provided me with. I'm not sure if things have changed since their initial version I used.
How'd you hear about it?
I feel like I heard about it through here, or maybe another group.
Maybe, yeah, maybe. I don't remember
in
it. But,
prior office hours, and then I just reached out due to getting started. They're
Okay.
definitely pretty responsive, need support.
Yeah, that's cool.
Yeah, for sure. I just looked at it in the getting started. It definitely says you need an API key like to pass it. So it's at least verifying some sort of credentials to enforce those limitations that they just wrote there.
I'm wondering how you provide the trust relationship into the individual cloud providers, like your AWS credentials and so forth. And if those are kept locally or if those are kept on their platform, then do you, Venkata, when you looked at it, how do you set up the trust relationship with AWS, for example, or whatever you tested it on?
That's a good question. So I used a test account for this, and I, if I remember correctly, I just had my AWS profile set up locally.
Okay, so it did use your local AWS credentials. Okay.
Yeah, Eric, in the provider multi, like the block for that thing, there's a sub block for each of AWS, Azure, and GCP, and it's just like you configure their providers just like you would any other provider, like an AWS provider. So like however you would normally provide credentials to your AWS provider, you provide it to the multi-provider the same exact way.
Yeah.
Did that make sense? What I said?
Yep, no, that made sense. I was I was contemplating what you were saying and weighing other things at the same time, but decided that not to bring that up. All right, well, so that was multi. Any other questions on that before I move on to the next announcement? All right, so anyone who's been using Terraform for some time and tried to integrate with a third-party HTTP endpoint might have encountered limitations using the HTTP resource native to Terraform. It only supports text, and that text has to be, I don't know, under 64K or even smaller. Maybe it's, I don't know, 4096, something really small that makes it pretty much useless. And you have no control over the request headers, and it only accepts responses that are text plain. So it's useless. Then you might have seen the MasterCard REST API provider, which is kind of cool, except for it's super opinionated on the REST API implementation. So most REST APIs, they're RESTful, let's say, they are RESTy, but they aren't. There's no universal standard, I believe, for REST and what the verbs and responses and structure of URLs and so forth are going to be. So when we tried using that provider, it didn't work for the REST endpoint we were trying to hit. So what I like about this is a generic implementation leveraging libcurl in Terraform, so you can make requests to some services. Where does this make the most sense? I think this makes the most sense, perhaps if you are working with some endpoint that accepts your JOT tokens, and you can use OAuth well, this is OAuth. I'm guessing there's one for OIDC as well, and then you can do more complex requests from Terraform to get some some value that you need to finish the rest of your Rube Goldberg apparatus. The other use case that we've had for being able to download files remotely like this is, well, if you want to distribute zip files for Lambda. Well, one approach that we took earlier on was to download that zip file locally and then provision it. So we had like an open source module. The other option, which we're pursuing now, which Matt Calhoun helped implement, is you can, of course, grant a permissive policy on that S3 bucket, but then you have to deploy it to every single region somebody might deploy your Lambda. So there comes a trade-off there. All right. Any other use cases for this curl provider that this solves problems for you?
What about updating like Snow or ServiceNow CMDB items, or pulling information to tag resources?
Yep, super easy for that now, or doing a quick request to the Slack API, for example, to send a message when something finishes deploying.
I would actually look at that to make Kubernetes API calls and avoid the Kubernetes provider in some cases.
Interesting. Yeah, bypass limitations maybe of providers. Interesting would be what are we just like you're annoyed you can't do something with the AWS provider. You can probably use the REST provider now just to make that raw request for that one-off thing that you need to do to get this whole thing working. So I see Matt looking dubious.
Yeah, I was just thinking about like how much control do you have over the state of the object that's returned, right? That's the problem. Like if you created a new AWS resource, where would you store all those properties of it so they could be referenced by, something else? You'd have to do some trickery to get that to work.
No. Well, that's where your mind went. My mind went in a different way, like the problems we had with DMS. So there's no way in Terraform to stop DMS tasks, a running DMS job. So with this, what one could do is orchestrate that using the AWS API directly to stop the task.
Yeah.
So basically for stateless operations, maybe one idea.
Yeah.
All right.
Who's the provider there?
Oh, for this one?
For
yeah, I don't remember. It was not a mainstream author. DevOps Rob. Out of London.
There's one from MasterCard as well.
Yeah, no, that was the first one I was talking about, the REST one.
Okay.
But that one's opinionated on the API and you can't make generic requests. We tried using it to automate, back in the day, we tried using it to automate the alternative to Artifactory. I forget what that product is, another open source one. Anyways, it didn't work with that API.
Talking about Sonar?
For what it's worth, DevOps Rob is sorry. I was just gonna say, for what it's worth, DevOps Rob is a HashiCorp DevRel.
Oh, really? Oh,
yeah.
Artifactory alternative. I forget what it was. Nexus is what I was thinking of.
Oh yeah, sorry. I think Sonar or Sonar Type is like
Sonatype. Yeah, Sonatype was, I think it's, company. Yeah, Nexus. Okay, thanks. Yeah, I think you were right. All right. Next announcement came across my desk was just a kind of informal postmortem by DoorDash, having run into some issues following a best practice of using health checks and readiness probes on their pods in Kubernetes. Who would have thought that could be a problem? Well, I think it's a problem. Like they brought up a number of issues, which was that they lacked any sort of telemetry on the actual outcomes of what those health checks were producing. So they weren't able to rely on whatever they had in place to monitor normal request failures. So they had to revert to looking at logs. Other issues they ran into were cascading failures. Basically, if you aren't wise about how your health checks are implemented, and your health check is actually not just testing your service, but checking or testing downstream services, and then when those downstream services degrade, then your service is considered unhealthy. That can cause these horrible cascading failures instead of degrading gracefully. The one thing I didn't see mentioned here, which I was expecting to see because it's something that's bit us many times, is health checks actually become like a swarm DOS attack at the upstream service sometimes, where if you have too many, as you scale out, you have more of these health checks happening, and you look at these logs, for example, and you'll just see like 500 health checks every 5 seconds hitting your service. Yeah.
Circuit breakers. That's why you need circuit breakers.
Yeah. Yeah.
So
Oh,
that
yeah.
when it fails, you have exponential back off, and then it sends one request, and then it goes into the half open state, and then figures out if that one request works, and then if that one request works, then you start trickling a few out until eventually a certain percentage succeed, and then you open the floodgates again. Like you have to.
But I mean, we're relying on Kubernetes. We're relying on Kubernetes' own readiness probes. I forget what the algorithm or strategy is there. The other thing I've noticed though with Kubernetes health check probes is, what was it? You can't force, without killing the pod, you can't just tell it to try again, I think is the gist of what I recall was the problem I ran into. All right, so that was just a lesson learned. We'll share the link in the channel for details on that. And the last one I thought is kind of cool. I've not had a chance to test it. I just saw it this morning. Was AWS announced, and I guess I didn't link this maybe. AWS announced support for managing your cases and doing live chat with AWS support via Slack. So not sure how well it works, but sounds pretty awesome. And you just need to add the AWS support app to your Slack team. Requires business class, enterprise on-ramp, or enterprise support plan. All right. Has anyone already tried this out?
Yeah, we're beta testing it in our org.
Oh, really?
Yeah.
How's it working out for you so far? Any gotchas?
Well, I'll still have to get some feedback. I'm actually just back from some PTO, so I'll get back some feedback and feedback into either the
that'd be cool.
Or...
Yeah, it'd be cool to, I don't know if you could share a kind of anonymized screenshot of what that might look like. And does it feel like a native conversation with a support rep through when you have the app installed and talking that way?
I guess the biggest challenge is still the age-old challenge of actually getting timely support. It's not like you actually have direct interaction with AWS support or named individuals either. It still goes through the same AWS support queuing system, and I mean, as much as I love AWS, that's always been like one of the biggest challenges that they've had to solve is actually staffing their support.
Yeah, my experience has been always incredibly pleasant. I've been impressed by the caliber of the engineers they have providing the support, but I don't interact with them as much day to day these days.
I'll weigh in on that. I'm a big believer in support, getting going to support. We've got business support. We enable it for sub accounts as needed, like they do it on a monthly prorate or monthly basis. But those guys are very good, and they like dig deep and come back with at least good starting places. In fact, I just had an experience with our data engineer where I was like, no, just do it. Just log the case. And like within an hour, he was a convert. Now he's like submitting cases all over the place.
And that's the problem with support, right? The better job you do, the more work you make for yourself. I wonder if there's any study on that.
Yeah, I'm actually curious how they map Slack to like accounts that have support enabled. You know, it seems like
yeah,
you know,
interesting, because they're real sticklers on that.
yeah, like open this case in this account. Like, I wonder how maybe there's a bot that you actually have to provide the account number or something when you open the case.
Or or create one support channel per account, maybe.
that would suck.
That would suck because we've got like 500 accounts.
Yeah, that's what I was thinking. Like, we work with a lot of customers that have a lot of accounts. That would be horrible.
So did you recall seeing how you selected the account, or?
No, so we have enterprise support on our root account, and by that it permeates through all of our accounts. We're a fairly large AWS partner, and generally have been a very proponent use of AWS. I'm ex-AWS staff myself, so I know exactly what goes on behind the scenes, and that's why I know the caliber of the guys that work there, but I also know the challenges that you have to face from the other side, being on the customer side.
It's going to be an enormous challenge.
Yeah. So I mean, but like I said, we actually started trialing it, doing the beta about a month ago, before they officially announced it. So I'll get some feedback from our members who've been on that. I've been on some PTO, so I'll get some feedback and I'll feed it back into Slack or into the next office hours.
Yeah, sounds good.
Eric, I just DM'd you. Oh, sorry, I DM'd you on the internal Slack, but it looks like basically they took the form for opening like a case in the web interface and basically just have it in like a Slack app that asks you all those questions. So, but if you open that, that's a link that shows you how they do it.
So, okay, that makes sense. Yeah. All right. I want to get into some Q&A here. Eric Berg asked a good question. Is there a deep dive video covering the Cloud Posse Way? And short answer is no, but what I want to do is start organizing activation days for Cloud Posse's strategy and helping people who want to use Atmos and Geodesic and those tools get started with some environment. I think we need to do a small test to learn from it and understand kind of what are the assumptions going into it that we had wrong or right, and how, what is the scope of doing something like that. But if you're interested in doing an activation day with Cloud Posse, it would probably be a few hours long or half-day session where we would have a handful of people on the call that we get up and running on that tool chain. So you can import and adapt your current tools and use that. So if you're interested, comment maybe on Eric's thread here in the office hours Slack, and we'll include you in that. And I'm also going to start a registration list so you can be included when we have those launched. The other question you had is like how context work. You've probably already seen our video on that one, Eric, but for the benefit of others, we do have a video on the context TF pattern. It's on YouTube, on our YouTube channel. The newer things that we have, the concept of fixtures and overall philosophy, some of that we have online as well. So we have our doc site, docs.cloudposse.com. Well, this is not our primary source of documentation for paying customers. It is what we have published and is available. Here we have some ideas of the philosophy and the concepts, and where we define the different things. It doesn't include some of the latest concepts, though, including multiple inheritance, mix-ins, and different strategies for how to organize your stack configurations. So those are more advanced topics. We should definitely get to having some documentation on that, but it's not there yet. And that's what's available right now for customers that go through the accelerator program. Anyways, you will definitely get a taste of what all of that looks like if we did one of these activation days. So keep that in mind. Any other specific questions I can help answer? Smaller in scope. All right.
I actually, yeah, that's it.
Yep. The next question I saw you also posted here. So you're building out a the Terraform code for an Aurora cluster, and would appreciate any input that you might have on that process. So, well, I'll jump into kind of how we would go about talking to a customer about it. And
I am using your module, by the way.
Oh, okay. That's helpful to know. So RDS, Aurora.
Preparing a PR to add separate tags to the reader and writers.
All right. Yeah, so actually we'll take this as an opportunity to groom our design decision in addition to informing on what we have right now, but I'd love to get feedback and input from everyone on what your experiences are, because that's how we improve our design decisions here. So I'm going to go ahead and edit this, so I'm ready to make any edits as we go. But so the typical strategy that we take when deploying RDS Aurora for our customers is to have one cluster per application stage. So like staging, production, and dev, for example. You could have multiple RDS clusters, but often the cost is somewhat prohibitive. And the idea is that you can have multi-tenancy on a cluster and achieve better performance as it grows and scales and you have more resources thrown at it. The other consideration is that RDS Aurora has limitations compared to working with perhaps a traditional RDS cluster, RDS instances, that at least at the time of this writing, you could only have 15 replicas. And that has been prohibitive for some of our clusters that, for some of our customers that were literally running, well, there was one, it was an education company, I think they were running in the thousands of database replicas because of some performance issues they solved by throwing more hardware at it. It used to be that point-in-time recovery was not supported, but we recently updated this to discover that it is now supported.
Backtrack.
Yeah, so those learning experiences. What else do we want to highlight here? RDS Aurora serverless just went GA. So that's an option now, and that might be a nice consideration for your lower environments, like a dev environment where you want to still have the same technology, RDS, more or less, but you want to reduce costs, and you don't need necessarily the performance or scalability of a dedicated cluster. I'm not sure, actually, from experience, RDS serverless, how it compares to your own dedicated RDS cluster at scale. Anybody using, for example, RDS serverless with like a large Lambda deployment?
Not with Lambda deployment on serverless, but with a traditional app. Mm-hmm. Yes, I've been using RDS serverless for quite a while. Some of the challenges with that you have to be considerate about when you're choosing serverless is serverless v1 versus serverless v2. Serverless v2 provides more granular ACUs so you can scale down to, I think, half an ACU, which you can't do with serverless v2. But serverless v2 offers multi availability zone scalability, which you would have as a more production performant serverless database, which again you don't get out of v1. So there are some cost and scaling considerations you have to be aware of as you're going between your different versions of serverless.
So what was that you were saying about zones or regions? I missed
that part. So serverless v2 offers multi-availability zone, which means you can have your DB subnets across multiple availability zones, and AWS very clearly documents that serverless v1 will only be created in a single availability zone. And if you were to have a cloud failure in that availability zone on v1, it is still a best effort. So serverless v1 is almost considered dev where serverless V2 is more UAT. I'll try and get the links for you and post them through.
It sounds like they'd be then sunsetting V1 then, no? Or have you seen any mention of that?
Yes. So again, I kind of turn towards Postgres. One of the things with Postgres is V1 only supported Postgres 10. And there was no upgrade path into higher versions of Postgres on V1 at all. Now, for those of you who follow Postgres, Postgres is sunsetting their V10 at the end of this year. And Postgres, so the only way to get into a Postgres 12 or Postgres 13 would actually be to create a snapshot of your V1 and recreate your V2 serverless cluster.
Okay. That's good feedback. Any other?
Yeah,
go ahead, Pepe.
Another thing that when we were working on replacing Aurora MySQL with Postgres for a really big database that needed replication, but it was used for high CPU joins or spikes in high CPU joins in MySQL. We moved to Postgres to using materialized views. And actually, we did a test on serverless, and for the same cluster that you needed to have the same performance in a serverless version V1 compared with the regular Aurora, it was triple the price to have the same performance because the type of CPU is not configurable. So we had to actually hardcode. We had to actually go back to regular Aurora. We didn't have the problem of the limitation of the 15 replicas, but that was a big problem. So if you are bound to a specific type of server due to the workload you do, serverless may not be the option.
Interesting. Basically, the issue is that just to basically the issue there wasn't enough granularity on the CPU types.
Correct. Yeah.
Okay.
Yeah. So they do say that V2 scales more performantly than V1, but the cost is a very big inhibitor.
So does V2?
I've just posted on the Zoom chat the link that has the comparison between V1 and V2 from the Amazon.
Oh, nice. Thanks. Oh, perfect. Thank you. I'll add that.
I guess the main thing is, I'm hoping to see, we have very spiky loads on some of these DB servers, so like they'll sit idle for hours, and I think we're hoping to, get some economy from whatever granularity we can get. Plus, with virtually instantaneous scaling, who can complain?
So one of the things I check, Eric, is I don't know your setup very well, but one of the issues that we had with Aurora clusters in the beginning was the HLCs being very high. And what
HRC?
HLC.
Yeah.
It's basically the file system, the pressure on the file system by the database. So Aurora works very differently in how it does the replication, in that it seems to be actually using a shared file system under the hood instead of a traditional replica.
Oh, interesting.
So if you think you're doing yourself a favor by putting all of your pressure, your request pressure on the reader.
Hold on. We got an audio here. Where's this? I couldn't.
I was already scared, and then that.
Thanks. I assume that was Linda who helped out. Thank you.
So you said if you think you're doing yourself a favor.
Yeah. So sorry, carry on.
So RDS Aurora replication happens at the file system layer versus the conventional database layer?
That's correct, yes.
It's a shared file system.
Okay.
It's kind of like a RAID 0 type of thing, or RAID 1 type of thing. There's a mix between RAID 5 and RAID 0s, and there was a talk on one of the RAID events where they went deep dive into how it was designed. And
it kind of looks like they can replicate at not only the database level, like locally, but they sort of replicate like their 10 gig data blocks across regions, because one of the things Aurora has is I guess is it called regional is the,
regional and
global, you can have this database replicated everywhere. Weird.
But what was that though thing? Was it Alan or you, Eric, was leading to that? One of the things you should therefore consider is if you're doing yourself a favor, what was the rest of that sentence?
It was Alan.
Yeah, that was me. So I said check on if you think you're doing yourself a favor by hitting all of your request queries on your read replica, there is actually a knock-on effect on your reader writer through the file system, because these aren't isolated the way that they would be in a traditional setup.
That same deep dive would go into some of their sharding and how they can, they basically need a quorum. So I think that they're probably a little smart about hitting unused shards or shards on less utilized infrastructure. It's kind of a guess.
Yeah, if you have multiple tables, you can actually have you can set up one of the replicas or a group of replicas under a DNS name, for example, and run robin against them, and it will actually automatically basically cache results within that pool of hard drives that you're hitting. But that's only on reads. Obviously you cannot do it on writes, but in reads you can actually do that. So you can sharding in a way, kind of like four-man sharding by just sending it up that way.
So Eric, just for your reference as well, I just put a link in again to the AWS docs, and I put a quote quite literally directly from that document. If you just look in the Zoom.
Wow. Interesting. Yeah. That's
10 minutes.
very good. Cool. Any other learning experiences from others using RDS Aurora that we should be good about sharing with everyone?
Whenever we present at a conference or talk about Aurora in a sales call or something, is going to be a sort of.
Sorry.
Yeah. Okay. All right. Well, thank you all for that help. That was cool. Eric, did we give you any more material for your research there?
Yeah. Couple things to look at. Basically we're at the point where I just got one spun up today. We have to make sure it's the right kind, like serverless and stuff, and then do some benchmarking. Unfortunately, it turns out that it's a replica, and in certain cases it's just pinned the entire time for its workload. So like that's hardly a baseline. Anyway, yes, thank you. And I'm putting the Aurora deep dive video into the chat here. I think that's the one, Alan, maybe you mentioned, but it's pretty deep. It's like goes into a lot of stuff.
Yeah.
So another interesting gotcha on this, it's come up for us. Not that you should ever have a database on public subnets, but there are companies that for legacy reasons or whatnot need it that way. Maybe they're using Heroku. Then you are in a pickle or a bind. You can set up an NLB to sit in front of it, but my understanding is there's no way to leverage security groups with that NLB to restrict access then to your database. I'm not sure if and I can't recall can somebody fill me in? What is the IP address of a client connecting via an NLB? Is it the originating IP address, or is it some intermediary?
The originating IP address.
It is the original. Okay, so then you can just use
it's
the RDS's security.
Yeah, it's a cut through proxy.
Okay.
So essentially, it just passes the original headers along to the server on the back end.
I guess it depends on whether that server then understands, like in the traditional HTTP conversation.
Well, we're talking NLB, not ALB, NLB, to be clear. Okay. I'm just confused because we were mentioning headers. I don't believe that's part of the NLB. Since that's
of course it is. No. I mean, every layer of the OSI model has headers. I don't mean HTTP headers. I mean, like the actual IP protocol source header gets rewritten as the like the source client. Yeah.
Okay, gotcha. Okay.
I'll keep you posted on that, and yeah, I'll see if I can get that PR together for separate tags on the reader.
Sounds good. Then let's see. We had one more question from the group. Going back to my notes here. What is the current best practice for storing the CA? So if you're using your own certificate authority, how do you pass the CA root cert to your applications or your Lambdas in this case, or ECS tasks?
I actually have it stored. I actually have it stored in my repo with my ECS task because I also refer to it in my connector. But I've also seen some people store it in a S3 bucket or just directly pull it at connection time. Just point to the URL and pull it if it's like an RDS cert that's been published. As long as you're not publishing your private component of your CA, you should be fine.
I think both of those are good strategies. Makes it easy to rotate it. The third strategy I would say is bake it into your base Docker images or your base AMIs. So you know it's automatically going to work everywhere you need it. Maybe it'll make rotation a little bit more painful, but it'll be an afterthought. Cool. We are almost out of time. We got about 5 minutes left. Were there any other questions? So Amtar, I saw your suggestion here about using AWS secrets. Yes, one can use AWS secrets or SSM. The question is then how does it get to the application? I guess the application can read directly from ASM or SSM and then leverage that when it sets up the connection. You could do it as part of your init scripts of the container that set up the environment before your process starts.
Rotation then needs a redeployment. Even if you're redeploying the same code, if you rotate your cert, you then need to redeploy your application so that it can read the updated cert from SSM.
Yeah. Which is a big problem because I believe you can't have two concurrent certificates online, or I guess you could possibly. I guess the issue is how do you do rotation then of those root certs in a way that doesn't cause forced downtime of your applications at the same time. So that's a good exercise to run through. Whatever your solution is, make sure you've practiced rotating it if that's going to be something you want to ever do.
Not with root certificates, but I've used in my node Lambdas, I use my keys I rotate, and because my key lifetime is a known like 24 hours, I don't have a key that's longer than 24 hours. I know that I can delete my old key after 24 hours and there would be no active clients after that. I guess it's a little bit more challenging with your database credentials. I'm happy to share at least a short write-up that I've done on that.
Yeah, for sure. Feel free to share that in the Office Hours channel.
Yep.
Wonderful. Well, we are out of time, out of questions. Everyone's satisfied. Have a great rest of your week, everyone. If you haven't already, subscribe to our channel. Go to youtube.com/cloudposse and stay abreast with all of our latest office hours that we have here. If you haven't connected with me, add me on LinkedIn. Go to linkedin.com/in/Osterman and add me. We do have a weekly invite that goes out, so you can add office hours to your calendar. Go to cloudposse.com/office hours to subscribe to that. And we have a weekly newsletter that aggregates all these cool links and things like that that we come across, so you can stay on top of what's happening in our industry. That's newsletter.cloudposse.com. You can go there to subscribe. Lastly, obviously, if you ever want to work with Cloud Posse, it's super easy. Just go to cloudposse.com/quiz. You'll be prompted with a few little questions just so we know a little bit about your situation, and then you can book a time with me directly. So I look forward to talking with you soon. Take care, everyone. Have a great rest of your week. Bye.
Thanks, everybody.
Cheers.